Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about the numerical based on the decay constant problem number 15, and here basically we are going to talk about how to solve this problem number 16. So let us talk about it in this topic. So friends, here is a question that is, a 3/4 of the original amount of the radioisotope decays in 60 minutes. What is its half-life? So based on this data, how we can calculate the half-life? So for that we have to understand this question. So here basically one data has been clearly mentioned, that is the change that has been occurring, it is in the duration of 60 minutes. So therefore what I can do is I can write the time, the data here as when t is 60 minutes. Here we have to understand this question, that is a 3/4 of the original amount isotope has been decayed. That means suppose what if we have 100% of the radioisotope. That means what I want to try to say is, suppose if the N naught is 100% and we know that is 3/4 of the original amount of the radioisotope, and the original amount is, suppose if it is 100% and 3/4 of the original amount, that is I could say that is out of 100 the 3/4 is nothing but it is the amount that has been decayed. So here basically we could get it will be around 75%. So that means 75% was the amount that was being decayed. So what is the amount which is left? The amount which is left, that is N is 100 minus 75, which is 25. So here basically, while getting to know about this statement very clearly, we have not only got the value of N naught, but also we have got to know about the value of N. So this is how basically we can solve a particular numerical. So not only we have N naught, but we have also N and we have time. So based on all these three data, we can easily calculate the decay constant, and from the decay constant we can easily calculate the half-life. So let us first of all find out what is the decay constant for this question. So friends, now we can easily calculate the value for the lambda by using the formula, that is lambda is equals to 2.303 divided by t log to the base 10 of n0 divided by n. So here basically we have the unit of time in minutes. So that's the reason that whatever the value of the decay constant we will get, it will have a unit of minute inverse. So let us write the things that is being required here, that is 2.303 divided by the time in which the change occurs from n naught to n is 60 minutes. So therefore we could write it over here, 60 log to the base 10 of n naught, which is found to be 100%, divided by the amount which has been undecayed after a duration of 60 minutes, and that has been found to be, that is 25. So here let us calculate this whole thing and let's see what is the value we could get in minute inverse. So let's calculate this one. So here we have got the value as 0.0231 minute inverse for the decay constant. But this is not the final answer. Obviously we have to calculate the half-life period. So for that we have a formula. T half is equals to 0.693 divided by lambda, that is the decay constant, and here we have the value for the decay constant in minute inverse. So therefore I could say that is 0.693 divided by the value of the decay constant, which has been found to be 0.0231 minute inverse. That means the unit of the half-life period, it will be in minutes. So let's see what is the value we could get here. So we have got to know about the half-life period as 30 minutes. So this is how basically we can easily calculate it in this manner, and that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope you have got to know about how to solve this numerical. So thank you for watching this, and I hope I'll see you next time. Till then, don't forget to subscribe to Ekeeda channel. Thank you so much.